For this experiment, you will need some clamps, stands, bosses, and the micro distillation kit. This reaction involves the dehydration of a substituted alcohol. So we're going to use 2-methyl cyclohexanol and phosphoric acid. We're also going to use boiling chips because boiling alcohols tend to bump when they get hot. Set up the distillation apparatus that looks like this. The power supply feeds the heating mantle. The heating mantle is supported on a upturned beaker. Round bottom flask is clamped to the stand. Thermometer is placed in the crick of the neck with the condenser, and we're going to collect our sample into little sample vials that we can seal. The water in feeds into the bottom hose, and the water out feeds to the sink. The cooling water does not need to be flowing rapidly, it just needs to be a trickle. Switch on the rheostat at a reasonably high temperature and begin to heat. Here, the round bottom flask has been preloaded with the alcohol, the acid, and some boiling chips. We're going to switch out the sample vials when we get to a recorded vapor temperature of about 110 degrees Celsius. After a few minutes of heating, the vapor at the crick of the neck is about 84 degrees Celsius. It is condensing, and we're going to continue to collect this until the temperature is close to 110. The sample vial for the first fraction has been switched out for a new vial. You can see that the remaining liquid in the reaction mixture is boiling away, but we're having a hard time getting the vapor to come across to get enough heat in it. So put a little bit of aluminum foil here to help keep the heat in before the condenser. The first fraction has been treated with anhydrous magnesium sulfate because there was visible water in with the alkene product. We're going to stop at this and keep it for the analysis stage. The reaction being studied in this lab is a dehydration of an alcohol. Now this is a secondary alcohol, which means it will make a good carbocation. So this reaction is going to proceed via an E1 elimination with the carbocation. First thing to do would be to protonate the alcohol. So this dehydration is going to be performed in acid. We're going to use phosphoric acid because it's less harsh than sulfuric acid. That will then leave behind a carbocation. Now here is where the reaction has to make a choice. It can choose either one of these two hydrogens to be abstracted by the base, and because we're performing this reaction in acid, our only base is water. I have two of them, and that's fairly easy to take, so I'm going to make the kinetic product right here. But if I try a little bit harder, because there's only one hydrogen here, and there is some steric crowding around it, that hydrogen, although it's harder to take, will produce the Zaitsev product. This is the lower in energy product, so it's the thermodynamic product. Something else to think about is that that secondary carbocation is just one bond away from a tertiary position, so it can undergo a 1,2 hydride shift. At this point, all four of those hydrogens are equivalent, and abstracting any one of them will generate this Zaitsev thermodynamic product. So we should see
a distribution. We should be able to see both of these products being made. And what we're going to investigate is what is the percentage product distribution? And did our distillation let us separate these two effectively?